given that 13 sine x plus 3 equals to 0, x is an element of 90 degrees and 270. So that means that x should be between the second quadrant and the third quadrant. Okay, so it's defined in any one of these quadrants. That's 180 and 270 degrees. So if it is sine, and then we find it to be negative, that would mean that it's in the third quadrant. So the first thing to read is, without using a calculator, evaluate sine, that is 360 plus x. If it's the sine, we can first sort this thing out so we can see what's the value of x, y, and r. To do that, we'll say root 13 sine x will be equals to negative 3. So we take the negative 3 to the other side. So then we'll divide both sides by square root of 13. Then the sine of x will now be minus 3 over root 13. You don't have to solve this because we're not going to use a calculator. So this is negative, so it means it's in the third quadrant. This is where the tangent is positive and the sine is negative. So this means, so we ignore, for the sines, we ignore the denominator. We look at the numerator. So the numerator is negative 3. So that means our y is negative 3. So now we can find the value of the x for this particular graph. Please ignore this particular x. We're talking about this x here. So x would be the square root of r squared minus y squared. So then this would be r squared, which is square root of 13 squared, minus y squared would be a negative 3 squared. Alright. Then this would be 13, and so this would be 13 minus 3 squared, which is 9, then the square root, and then this would be 13 minus 9, which is 4. The square root of 4 is 2. Now since we are in this side of the Cartesian plane, on the second and the third quadrant, our x is expected to be negative. So then we'll have x as negative 2. So now we have negative 2 for x, and our y is negative 3, and our r is the square root of 13. Now that we have this, we can answer this question. Jolly good. The sine of 360 plus x. Now 360 plus x, if you have this plane here and you start at 0 and it will end at 360 again, if you do a whole loop 360 plus an acute angle x, you will end up back in the first quadrant. So if we were to reduce this, the sine x will be positive and is reduced. So we know already that the sine x for this particular expression is minus 3 over square root of 13, as defined by minus 3 over the square root of 13. Then the tangent of x for the tangent of x, this is straightforward, no need to do any kind of funny stuff, is defined, tangent of x is defined as y over x. This is what makes this thing positive anyway. So this will become minus 3 over minus 2. Please ignore this x. Think of this x as theta. But this one is just your general expression for when you do your sine ratios. When I say ignore, I don't mean it's not there, but it's an angle, not this x. So this will be minus 3 over minus 2. So it's going to be 3 over 2. And then finally, let's do cosine of 180 plus x. I don't even know why they do this, because already each, whether it's in the second or the third quadrant, is defined to be negative. Probably let's find out. There might be a good idea for that. This is 180 plus x. If we have our Cartesean plane and this is where our 180 is, our angle goes there, and a little bit of an acute, it will come right here in the third quadrant. Now in this quadrant, cosine is negative, so this becomes cosine x. Ah, that's why. So this is minus cosine x would be x over r. Our x is negative 2. Our r is square root of 13. So then minus times minus is positive, so this is 2 over square root of 13.